Hi class, so today we're going to go over some more questions on the Pythagorean theorem. Okay, so the first one says, which side lengths form a right triangle? So in this case, if it forms a right triangle, right, we should see the Pythagorean theorem. So a squared plus b squared is equal to c squared. So which side lengths form a right triangle? Choose all answers that apply. So this says choose all answers. There's going to be at least one correct answer. There might be more. Okay, so we pretty much have to try all these answers out. So one thing to remember is that the C value is the largest value out of the three sides. Okay, so we have to see, so we have 3, we have radical 27, and we have 6. What is radical 27? Well, I know that radical 25 is equal to 5. And radical 36 is equal to 6. So this number is in between that. So it should be in between 5 and 6. So 6 is the largest number here. So I'm just going to put 6 here. That's the largest number. And then the other two are interchangeable. So 3 squared plus radical 27 squared. 3 squared is 9. Okay. Radical 27 is just 27. That's equal to 36. 9 plus 27 is 36. Is 36 equal to 36? Good. So this forms a right triangle. Okay. Now we have to try the other ones. 5 and 17. So I know from the Pythagorean triples, okay, that 8, 15, and 17 is in fact one of the Pythagorean triples, so that is also correct. If you don't know your Pythagorean triples, you just have to plug it into the formula. I already know it, so I can save some time. And now let's try a third one. So 5 squared plus 5 squared is equal to radical 50 squared. I know that radical 50 was the largest value because radical 49 is equal to 7. So radical 50 has to be a little bit bigger than 7. Okay, so that's why it's the largest value. So we have 25 plus 25 is equal to 50. That looks good. Okay, so therefore it will make a right triangle. So all three will make a right triangle. The second one. Okay, so same type of question. So you have to write down the formula first. Okay, we always write down the formula first. All right, and then the first one, 1 squared plus 5 squared is equal to 26 squared. So I have 1 plus 25 is going to be equal to some large number. Okay, so 26 squared is 676. So I know that this is not true. So therefore, it will not be a right triangle. Okay, let's try the second value. 1.5 squared plus 2 squared is equal to 2.5. Okay, this ends up becoming 6.25. Oh, this one's squared. And that's equal to 6.25. Yep, so that's good. All right, and then the last one, we have 4 squared plus 4 squared is equal to radical 32 squared. 4 squared is 16, so 16 plus 16 is 32. Radical 32 squared is also 32, so that is good. So these two are the correct answers. Next one. Okay, so for this, which could be areas of the smaller triangle, right? The area of the largest is 36. So first thing I'm going to do is fill in 36. That's the largest one. It should go on the hypotenuse. Okay, hypotenuse, which is always across the right angle. And which could be areas of the other two smaller squares? Choose all answers. So for the other squares, okay, the two smaller ones should add up to the larger one. So in this case, 6 plus 30 is 36. Good. 8 plus 28 is 36. Good. 4 plus 16 is 20, so that's not good. Okay. The area of squares adjacent to the two sides are shown below. So they give you the areas of two triangles. And we have to find out the area of the square that's adjacent to the third side. So in this case, I see the areas. So in this case, this would be c squared, okay? Represents the area of this side, right? So c times c, which is c squared. Over here, this will be b squared. Doesn't matter. You could be a squared if you want, but let's do b squared. And this area is going to be a squared. We know that a squared plus b squared is equal to c squared. So we have some value plus 33 is equal to 44. The area is going to be 11. Okay. Next one, what is the area of a square that shares a side with the third side of the triangle? So I want to find the area of this. So this is going to be c squared. So in order to do that, I know my Pythagorean theorem. So a squared plus b squared is equal to c squared. Okay. Well, my a value is 2. My b value is 4. And it's equal to c squared, which is what I'm trying to figure out. So 2 squared is 4. So we have 4 plus 4 squared, which is 16. Okay, and that's equal to c squared. 4 plus 16 is 20. 20 is equal to c squared. And that's it. I'm just going to keep my answer just like this because we're looking for the area, okay, which is c squared. I do not have to figure out what c is. Okay. All right, and then this last one. The areas of the squares adjacent to two sides are 29.25 and 13. Okay, so they give us the two legs. We have to figure out the hypotenuse. So find the length of the third side of the triangle. So I'm just trying to figure out what C is. Okay, this is going to represent C, just the thirds, the length. Okay, not the area, but the length. Okay, so I have A squared plus B squared is equal to C squared. So I have the area already over here, 13. The area, which is 29.25, and that's equal to C squared. All right, so 13 plus 29 is 42.25. That's equal to C squared. But I'm looking for C now, right? Just a side length. So you need to take the square root of that value. Okay. And if you take your calculator on your phone, right? If you have an iPhone, you can turn it sideways and it'll give you the square root button, right? It's gonna kind of look like this with 2 on it as the root. So once you press 42.25 and then the square root button, you're gonna get 6.5. Okay, and that would be the length of the third side. All right, next question. What is the perimeter of the parallelogram? Okay, so notice how in this parallelogram, okay, you have this diagonal. Well, you have two diagonals here. So one thing we can do is we're going to split it up. Okay, so I have this right here. Let's split up with this. Okay, so first now what we made is two triangles and a rectangle. Okay, if I want to find the perimeter, it's the outside, okay, this blue line right here, and just add them all up. Okay, so let's figure out what the hypotenuse is, because this is going to be a right angle triangle. So you have 4 over here and 3. Okay, so this side length has 3, this has 4. So you would use the Pythagorean theorem. Okay, a squared plus b squared is equal to c squared. okay? But if you know your Pythagorean triples, you know that 3, 4, 5 is a triple, okay? So 3, 4, and then the hypotenuse has to be 5, okay? And over here, this is also 4 by 3 triangle, so this is going to be 5, okay? I'm just going to erase the middle now that we know the hypotenuse. All right, so that's 3. We're missing 1 here. Okay, we're missing 1 here before, and this is 3. Okay, so we have 4 plus 4 plus 5 plus 5. So 4 plus 4 plus 5 plus 5 gets us 18. All right, so 18 is going to be the perimeter. All right, next one, what is the perimeter of the triangle? So in this case, it's an isosceles triangle. So the same thing as what we did before. We need, in order to figure out this diagonal right here, you need to split it up into a right triangle, okay? And I'm just gonna write the side lengths over here. So the bottom one is 5. The top one is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is 12, okay? And I want to figure out what the hypotenuse is. So in this case, it's going to be the C value. So you can use, you know, a squared plus b squared is equal to c squared, right? Just fill it in. So you have 5 squared plus 12 squared, and that's equal to c squared. I know my Pythagorean triples, so 5, 12, and 13 are triples, so c is equal to 13. Okay, so c is equal to 13. Now I can use that to figure out the perimeter. Okay, so 13, all right, on the other side is also 13, since it's an isosceles triangle. Now the bottom one, before we said that this right here was 5, right? So the other half should also be 5. Now we have 13 plus 13 plus 5 plus 5, and this is going to be 36. Next one, now we're talking about area. Okay, so for the area of the triangle, you need to know the formula for the area of the triangle. It's going to be area is 1/2 base times height. Okay, so we have to find the height of the triangle. We have the base. We have to find the height of the triangle. The height of the triangle is the line that goes straight up, not the diagonal, but the line that goes straight up to the altitude. Okay, so that is going to be the height. Okay, and so when I make this line, it makes 2 triangles, right? It's going to split the base in half. So I'm only looking at this triangle right here, right? Because I want to make it into a right triangle, so I can use the Pythagorean theorem. So 13 is the hypotenuse. The height, we don't know, so that's going to be x. And the base, well, the base is just half of this, so this is going to be 5 now. Okay, so now I have my triangle. So I'm using the Pythagorean theorem first. Okay, so a squared plus b squared is equal to c squared. So I have x squared plus 5 squared. That's equal to 13 squared. So x squared plus 25 is equal to 169. And I knew it was a 5, 12, 13 triangle anyways. So x is going to be eventually become 12. Okay. So now that x is 12, I'm just going to fill that in for the height. Okay. So now I have the base, I have the height, I can find the area. So area is equal to 1/2 the base is 10, the entire base is 10, and the height is 12, okay? 1/2 times 10 is 5. 5 times 12 is 60. So the area is 60, okay? And that is the answer. All right, next one. What is the area of the following right triangle? So we have the base is 5. The height, we don't know. Hypotenuse is 13. So this is pretty much the same thing as before, right? So we have the Pythagorean triples, okay, which is either 3, 4, 5, or we have 5, 12, and 13, or we have 8, 15, and 17. Those are the most common ones, so you should try to remember those. So in this case, the last number, well, in all cases, the last number is the hypotenuse, right? So hypotenuse 13. Oh, maybe it'll be the middle one. We have a leg of 5, and the other leg is 12. So we have one leg of 5, the other one has to be 12. Okay. If not, you just do the formula like what I did for the previous question. So this is going to be 12. Area of this right triangle. So area is equal to 1/2 base times height. Okay, and we have 5, which is the base, and the height, which is 12. 1/2 times 12 is 6. 6 times 5 is 30. Okay, and that's the area of this triangle right here. All right, next we have this parallelogram. So area of a parallelogram is base times height. Okay, so I have the base. Okay, base of 4. And we need the height. So I'm just missing this part right here. Okay, this is going to be our unknown, our x value. So if you look over here, they made a triangle. Okay, it's 3, this size of 3. I'm missing this, and then 5. So it's going to refer back to our 3, 4, 5 triangle. So x is going to be 4. Okay, if you didn't know that, you just use the Pythagorean theorem to find out. So now I know the height. Okay, the base is 4, so area is equal to 4 times the height, which is 4 again. So area is 16. Okay. And the next one, area of a trapezoid. Okay, so area of a trapezoid is base 1 plus base 2 times the height divided by 2. Okay, so for this, it doesn't matter which one base 1 or base 2 is. Okay, so let's see. So let's label them now. So base 1. Okay, so the top one could be base 1, right? The bottom line is base 2. So in this case, I have 4 here. Okay, but what's this part? This part also has to be 4 because it's a rectangle. The two sides should be equal. Okay, and then I'm missing the height over here. So in this case, we have this triangle, 4 and 5. So it's 4 and 5. We go back to the Pythagorean theorem. Oh, 4, 5, the leg should be 3. So this is 3, which means that this side is also 3. Now I have 2 bases. I have the height. Okay, so area is equal to base 1, which is 4, base 2, which is the entire bottom part right here. So 4 and another 4, which gives us 8. Okay, so 4 plus 8 times the height. The height is 3. And divide all of that by 2. 4 plus 8 is 12. 12 times 3 is 36. 36 divided by 2 is 18. So the area of this trapezoid is 18. All right, next one. Now these are just some word problems, so you have to draw out the question. So Elise walks diagonally, right? So that's slanted line, from one corner of a square plaza to another. Each side of the plaza is 50 meters. Okay, so you have a square plaza. And Elise walks diagonally. So she walks like this, from one side to the other corner, okay? Each side of the plaza is 50 meters. So I'm gonna put in 50 and 50 here. I'm trying to figure out the length the diagonal distance of the plaza. So this is the hypotenuse over here. I have 50 and 50. Okay, so this is an isosceles right triangle, and because there's a right angle right here, since it is a square. So knowing my special right triangles, right, this is going to be a 45, 45, 90 special right triangle. So the sides are x, x, and then x. The hypotenuse is x radical 2. In this case, x is 50, so the hypotenuse has to be 50 radical 2. If you don't know that, just use the Pythagorean theorem. It's the same thing. Okay, and then I have to round to nearest tenth of a meter. Very important, or else your answer is going to be incorrect. So nearest tenth. So I would plug in 50 radical 2 in my calculator. It ends up being 72. So let me just write it down. 50 radical 2. When I plug in my calculator, it becomes 72.1249. Okay, so I want to round to nearest tenth. This is the tenths place, the one right after the decimal point. The number after is a 2, so it's going to round down. So it's going to become 72.1. That is your answer. Next one. Steve turns half his backyard into a chicken pen. His backyard is a 24 by 48 meter rectangle. So I draw a rectangle first. Okay. So 24 by 45. So 24, 45. He wants to build a chicken wire fence that stretches diagonally. So he wants to find out this diagonal length. Okay, and that's going to be our x value. So how many meters of fencing will Steve need? So we're trying to figure out what this is. Okay, 24, 45. Is this one of our Pythagorean triples? It doesn't look like it, okay, because it's not a multiple of any of them. So in this case, we have to use the Pythagorean theorem then. Okay, so we have, I guess we'll write the formula first. Always do that. Helps you remember it as well. So that's the hypotenuse. So we're just missing the c value, okay? So we have 24 squared plus 45 squared. All right, so 24 squared is 576. All right, and then 45 squared is 2025. All right, so when you add the two together, you get 2601. Okay, so just pull this up. So 2601 is equal to x squared. So then you have to take the square root of both sides. Okay, and then you get x is equal to 51. Okay, so how many meters of fencing will you need? 51. Okay. Next question. All right, so this one is the diagonal length of it. Okay, so this is from the top corner to the opposite corner on the bottom. Okay, so this is a little bit different for your Pythagorean theorem because it kind of makes you try it twice. Okay, but a little trick that I learned over the years is that to find this three-dimensional diagonal length, okay, the formula is this. So you have, oh, so actually, let me start it the same way. So it's going to be a squared plus b squared plus c squared. That's going to be equal to d squared. Okay. So we have 2, 5, and 8. All right. So the length, width, and the height are all going to be values of a, b, and c. All right. And d is just the length of the diagonal, the three-dimensional diagonal, going from one corner to the opposite corner. So you have 2 squared plus 5 squared plus 8 squared. That's equal to the square. So we have 4 plus 25 plus 64. So 4 plus 25 plus 64, that gets you 93. Okay, that's equal to d squared. So d is the square root of 93, and the square root of 93 is going to be 9.64, and then it says round to the nearest tenth, so it's gonna be 9.6. Okay, that's how you. If not, you just try the Pythagorean theorem twice, and you can still get it. Okay. All right, over here, you have this isosceles triangle. Okay, so you know is that it's an isosceles triangle. So we have 3 radical 2 for the hypotenuse. We have 6 for the base of that right triangle, and we need to find out the height. Okay. So in this case, in this triangle, I can just draw it again to figure out the height. So we have 3 radical 2 on the hypotenuse. H is what we're missing, and then 6 is the entire base. So this half of the base is just 3. Okay. All right, so let's figure out what the height would be. So using the Pythagorean theorem, so at h squared plus 3 squared is equal to 3 radical 2 squared. So h squared, 3 squared is 9. Okay, and now over here, 3 radical 2 squared. So everything gets squared. So 3 squared is 9, and then radical 2 squared is 2. So this is 9 times 2. Okay, so h squared plus 9 is equal to 9 times 2, which is 18. H squared is going to be equal to 9. H is 3. So the height is going to be 3. Next question. Okay, so this is the distance between points. Okay, so you get 2 points. So what you should do is you should draw a triangle from those 2 points. So in this case, you have the diagonal length, you have the horizontal length, and then you have the vertical length. Okay, so now with this triangle, you can figure out what this is, the hypotenuse is, okay, since you made this triangle. So the height is 2, and the base goes from -5 all the way to 4. So this has a length of 9. Okay, so we have 2 and 9, and now we just plug in. So 2 squared plus 9 squared is equal to c squared. 4 plus 81 is c squared. C squared is 85. So c has to be radical 85. What is the length of the line? Well, this is going to be 4. The height is 3. All right, so Pythagorean triples, 3, 4, 5. There we go. All right, now this last one. What is the distance between -9, -6, and -2, -2? Well, you know that it's going to be a diagonal length, okay? So you can kind of just draw this out, rough sketch. So -2, -2, that's in quadrant 3. And -2, -2. -9, -6 is even deeper even further away from the origin in quadrant 3. So I'm just going to draw that right here. -9, -6. Okay. So now that I know the line looks like this, I can pretty much draw a triangle from that. So I have the height of the triangle, which is a change in the y value. So it goes from -2 to -6. So this is going to be 4, a length of 4. And then -2 to -9, this is a length of 7. So 4 and 7, we need to figure out what the hypotenuse is. 4 squared is 16. 7 squared is 49. That's equal to c squared. 16 plus 49 is 65. So c is equal to radical 65. And answer choice C would be correct.